1.6. Determine a quadratic equation given its roots. What we're doing here is we're going to use the zeros to be able to find the equation of a family of quadratics functions with the same x-intercepts. What a family means is that it's a group of parabolas that would share the same characteristics. And in a case of a family with zeros, means that they all share the same zeros, but they might have different stretch and compresses, for example, a values. Now, to determine an individual quadratic function, you also need to be given one other point on the actual function in order to find that equation. Now, that is a specific equation targeted to a specific parabola that has the same zeros and goes through a specific point. That gives you an individual equation. Now, there are different forms of quadratic equations that could be expressed. For example, the first one being vertex form, y equals a x minus h squared plus k. Another one is y equals a x minus r times x minus s. That's known as the factored form or zeros form. And finally, the last one is in standard form. Y equals ax squared plus bx plus c is known as standard form. And parabolas can be displayed in different forms which help you identify features of the graph. Example 1. You're asked to write the equation of a quadratic function whose only x-intercept is 5 and passes through -1, -8. What does this mean? What is it saying? Well, if a parabola has only one x-intercept, means that that x-intercept is also the vertex. And we need a specific equation because it passes through a specific point. So we're going to use the vertex form to be able to solve this. But in order to do that, you need to state what you are actually planning to do. So you're asked to sub 50 for hk in -1, -8, and -1, -8 for x and y. So 50 is being subbed for h and k, and -1, -8 for x and y. That's our point into the generic equation in vertex form. So you have to state this because this is telling me that you are going to do the following in order to solve the problem. So we plug in our y, our a stays the way it is, our x, our h, and our k. Don't forget the square in the vertex form. At this point in time, you solve for a. So we solve for a, and we find out that the value is going to be -2/9. How? Well, let's go over this. If there was a number here, you would subtract it over here. Inside here, -6 squared is 36, so it would be 36a plus usually a number, which moves over, and then you divide by 36. And when you reduce it, it becomes -2/9. But that isn't the final answer. That is only the a value. You now have to write the equation. Because it doesn't say what form it's in, you can put it in any form that you choose. In this case, we have the vertex, so let's put it in vertex form. So therefore, the equation is y equals -2/9, x minus 5, all squared. And that, folks, is the final answer for part A. Okay, part B. You need to find an equation whose family has roots at x equals -1 and x equals -4. What that means is that we're finding a general equation and not a specific equation. We still need to list the information. So we're going to sub r is equal to one of the roots and s is equal to one of the other roots. Just note, you had that number. This got just changed for a second just so that we can see a little bit harder question than the simple, straightforward one. So we plugged in negative 1 over 2, and s equals negative 4 into the factored form equation. And what you end up getting is y equals x plus 1 over 2 times x plus 4. I don't know about you, but I never remember seeing an equation factored in such a way. We've always seen numbers here where there's always integers in these values. Well, that's true here too, folks, because this isn't the final answer. What you now need to do is put this in the proper form. What is it? Well, the 2 goes to the front so that you have y equals a 2x plus 1 times x plus 4. You're only multiplying this case, this one over here, you're multiplying this whole bracket by 2 in order to get 2x plus 1. And the other one is just going to stay x plus 4. They both don't get multiplied by 2, only the first one does. All right, so this is the generic equation for a family that has roots at negative 1 over 2, and that's what you would see here, negative 1 over 2, and the other root would be at negative 4. Okay, let's look at another example. Part C, whose x-intercepts are x equals negative 2 and x equals 4, and passes through a point negative 1, 3. And you want this equation in vertex form. What does that mean for us? Well, again, you need to state what you're going to be doing. Just a quick statement. So the statement will be sub r equals negative 2, s equals positive 4, and the coordinates negative 1, 3 for x and y. And we're plugging it into the equation in factored form this time. So we plug it in, our y, our x, our r, our s, and then we solve it very quickly to find out that the a equals negative 3 over 5. How did that come? Negative 1 plus 2 is 1. Negative 1 minus 4 is negative 5. Multiply those and divide, and you get negative 3 over 5. That is the equation y equals negative 3 over 5, x plus 2, and x minus 4. That is your generic equation for this problem. Now, this equation is not in vertex form. So we're actually not done yet. We've got our general equation, but in the wrong form. We need to get this in vertex form. So let's move on to the next page and recopy this question onto the next page. So we have this. Where did this come from? Well, I just want to show you what happened. In the original... Okay, so we're looking at this question. We're going to repeat this onto the next page so we can work with it. So we have the equation in factored form, and we want to make it into vertex form. So naturally, our first instinct is to expand the double set of brackets, collect like terms, and expand it. That's what happens here, folks. I'm going to stop here for a sec so you can look here that negative 4 plus 2 is going to be negative 2x. But then when I multiply it by negative 3 over 5, that's how I got plus 6 over 5. Just so that you understand where I got those numbers from. And then plus 24 over 5. Next, you're to remove the a value from everything that has a variable. Once you do that, you then complete the square by doing the following. So we have, take this number, divide by 2, bring out the square, so it's just x minus 1 squared, and then minus, all the time minus, 1 squared, exactly as you see here, times by negative 3 over 5, and then plus 24 over 5. So our final answer is going to be negative 3 over 5, x minus 1 squared, plus 27 over 5. Now, this is not the only way a solution can be done for this, because this final solution is the equation in vertex form. But what if you manipulated it differently? Some of you remember that last year you learned that in between the zeros is the x value of the vertex, and that is always true. So I have our zeros here, and if I add them up and divide by 2, that will give our h value. That is the x value of the vertex is h, remember? So now we actually have some of our equation for vertex form. So if you didn't understand how to do it this way using algebra, there is a sneak backwards way to look at it. You could literally plug in h equals 1, our a value that we found on the other page, which is a equals negative 3 over 5, and we're going to plug in negative 1, 3, which is the coordinates that you were given in the original question, for x and y, and we're going to sub it actually into the vertex form and find the value of k. So we plug in our y, our a, our h, and our x. We plug in the numbers, simplify the expression. Now if you're wondering where these values came from, let's go through this. Negative 3 over 5, that's your a. So negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times negative 3 is negative 12 over 5 plus k. Move it over, common denominator gives you 27 over 5. And guess what, folks? That turns out to be our equation. Y equals negative 3 over 5, x minus 1 squared, plus 27 over 5. So if you do it the blue way or the black way, I guarantee you'll end up with the same answer, provided you've done the math properly. Part D. We're going to be looking at find an equation whose zeros are at 2 plus or minus root 5 and passes through 1 negative 12. What you're asked to do is express the answer in standard form. So this one requires a bit of processing and thinking. So we're going to go through this one a lot slower. First of all, we know we have to sub in each of the zeros, the plus and the minus, in for r and s. So those are our zeros. And we plug in the coordinates for x and y. What you're to do next is to put it into the factored form, all that information. So y will go in for negative 12, a will remain a, x will be 1 minus, and then r, which is 2 plus root 5, and then 1 minus 2 minus root 5. And what that does for us, folks, is set up the roots for us. Once we know that, we can expand it. Now, this is a good practice for you. I'm sure you could find another method to be able to find this, but the idea is that if you learn how to expand with radicals, it'll make it a lot easier understanding, and you don't have to try and find a backdoor way into things. So what I want you to do is take 1 minus 2 minus root 5. That's what I did, is I expanded that. And 1 minus 2 plus root 5, because the minus and the minus make a plus. And I want you to simplify that, so that you get minus 1 minus root 5 and minus 1 plus root 5. Where did that come from? That's usually a question that I get. 1 minus 2, guys, negative 1. 1 minus 2 over here, negative 1. That cannot combine with the root 5. That's what we end up with here. I want you to look at this now and see something that you should recognize from your previous years in math. And that's right. You should notice that it's a difference of squares. You have a minus and a plus with the same values at the front and the end. So, what is that? That's a difference of squares. So, if you were keen enough, you would notice that you could expand this using a difference of squares. And that would save you a lot of grief rather than trying to write it out this way as I've written here. You could recognize that it actually is a difference of squares. So here's an example of how it could be a difference of squares. So, looking here, you have a difference of squares. Difference of 2 squares. That's exactly what this will result in. It will result in 1 minus square root of 25, which is just 5. And 1 minus 5 is going to be negative 4. This middle root 5s, they actually disappear, because difference of squares will disappear the middle term. Anyway, so you got negative 4 here. We're going to divide both sides by negative 4, and we end up with an a value of 3. Now, the trick is that it wants the equation not in factored form, which would be easy for us, but it wants it in standard form. Because ultimately, our quadratics will show up usually in standard form, especially those that have weird roots, because we would use quadratic formula. So, we're going to take this a value and sub that a value, as well as each of the roots, into the equation, and that's the factored form equation. We plug it in as such, And hopefully you see something here. If you don't, you will see it in a second. If you see it here, you can see that it's almost like a difference of squares. But they have the same beginning and end for each piece, with a plus and a minus in between right here. Interesting. So we could use the concept of difference of squares again. And we do, and expand. Now this is the key. You have to remember that you got to expand it. So the x minus 2 gets squared, and the root 5 gets squared, which just gives you 5. X minus 2 squared, though, gives us a little bit more complicated question. X squared minus 4x plus 4. And then we have the minus 5. Expand that all out, we get y equals 3x squared minus 12x minus 3. So this is the final equation that we're looking for in this problem. I think this is kind of neat and interesting to look at, so I want you folks to try and do some examples. I'm sure there is some homework questions that involve this. This, though, folks, would be an inquiry question. It wouldn't hurt to try it again. All right, last one. You're asked to determine the equation of a quadratic function whose graph looks like the following. There we go. So, what do we do when we have a graph and we need to determine the equation? Well, we need to determine some of the features of it. We can look at a point, okay, 2 points being the zeros. We can look at maybe a y-intercept or another point, or we can look at the vertex. It's up to us. But the goal is whether you use vertex form, standard form, or factored form, you should be able to get the following equation in standard form. By using the zeros and a point, you would get values that you plug in as such and to the factored form equation, and you should get an a value of 2. So the equation is the following. Now that would be if you want it in factored form. In vertex form, it would be y equals 2 x minus 1 all squared minus 8 would be factored form. Finally, in standard form, it would be as follows. Y equals 2x squared minus 4x minus 6. That would be in standard form. So now you have the different way the equations can be. Go ahead and try it to get some practice. All right, that's the end of the video, folks. Take care. Have a numerical day.